So here's the questions 8 and 9 from the mechanics practice test, and we'll just work through these as well, so you've got a complete set of notes on this if you want them. So let's get started. Let's pick out the key things from the questions as usual. So let's read it. A particle mass 6 kilograms, initially at rest, and a force AI plus 10 J newtons on a bearing of 300 degrees. Okay, that's not a great question because it's not defined the I and J relative to north in the question. But we better do that at the start, and we'll take the standard thing where I is east and J is north. On a bearing of 300 degrees, so that would make that angle 60 degrees, 300, so 270, that angle in there would be 30, and that's R. Okay, so this length here is A, but actually it's negative A if we're really precise. Well, it's, A, we could do it like that. And B then is, that height there is 10. Sorry, that's squeezed in on the edge. Okay, find the exact value of A. So if we work with the 30 degree angle, tan of 30 is equal to 10, the opposite over the adjacent A. So A equals 10 over tan of 30. And then tan of 30 is 1 over root 3. So A is 10 root 3. But the key thing, if we look back at the diagram, if we take that and look back at the diagram, A is actually in the negative direction. So A is equal to minus or negative 10 root 3. Okay, part B, the magnitude of R. So the magnitude of R is equal to negative 10 root 3 squared plus 10 squared using Pythagoras. So that's going to be the square root of 400, which is 20 newtons. Part C, work out the magnitude of the acceleration. And again, the key word again is the magnitude of the acceleration. And because we want the magnitude of the acceleration, we can use the magnitude of R. Is going to be fine as the force. So we're going to apply N2, apply N2, and we get F equals MA. The magnitude of the force is 20. The mass, if I remember rightly, was 6. Just check that. So 6, and at the acceleration A is what we're working out. So A equals 10 over 6 meters per second squared, which is 20 over 6, which is 10 over 3 meters per second squared, or 3.3 recurring, if you'd rather. Okay, part D says the time it takes the particle to travel a distance of 640 meters. So we've got to notice that the force is constant. Force is constant. Therefore, the acceleration is constant. So we're in a SUVAT context. So we're going to go constant acceleration. U, well, what were we told? Particle starts at rest, initially at rest, so U equals 0. A we've worked out to be 10 over 3. We've been asked to find the distance, so time it takes to travel a distance of 640 metres. So S equals 640 and we want the time. So equation will be S equals UT plus a half AT squared. So 640, U is 0, T plus a half, A is 10 over 3, T squared. So we get 640 times 6 over 10 equals T squared. So T squared equals 64 times 6. Oh, that's square rooting it, makes it nice and easy, because that gives us square root of 64, square root of 6, which is 8 root 6 plus or minus. But in this context, we only need a positive value, seconds. If we tap that in the calculator, it's going to be approximately 1920. Comes out to be 19.6. There you go. Seconds. Okay, question 9. So here again, let's start by reading the question carefully, lift out the key information. So question 9, particle P. It moves along a straight line, appears initially at rest at the origin. On the line at time t seconds, the velocity is given by a function of t. So the key thought at the start, v is equal to a function of t, therefore not suvat, or not constant acceleration. Use calculus. That's what we're thinking at the start of the question. Okay, so it's a calculus question. So V equals 1 over 20 lots of t times 5 minus t squared. And if we're in a calculus context, we like it in our polynomial kind of form. Whoops, what have I done now? Go back, cancel. Oh dear. I don't seem to be able to get rid of this page. No. Oh, gadget. There we go. So we've gotten back to our normal page. Sorry about that. Okay. I found how to do it. 5 minus t squared. Okay, now if we were in the calculus form, we need to expand that. So we get 1/20th of t times 5 minus t squared. So 1/20th of t, 25 minus 10t plus t squared. Expand it out. So we still want that k, what we tended to refer to as our want kx to the n form, a polynomial form for differentiating for calculus. Yeah, we need that structure. So we've got 25 over 20, which is 5 over 4t, minus 10 over 20, which is a half t squared, plus 1/20th of t cubed. Okay, so we identified it was a calculus kind of question. We've got it into our kx to the n, or our polynomial form, which we like when we're in a calculus context. And now let's go back and see what we've got to do with it. So find the values of t and the corresponding values of v when the acceleration of p is 0. So if we want the acceleration, we know that we have to differentiate. So dv dt, the derivative of the velocity, the rate of change of velocity is equal to acceleration, which is 5, write down the constant, derivative of t is 1 in effect, write down the constant, bring down the power, subtract 1 from the power, plus write down the constant, bring down the power, subtract 1 from the power, tidy it up, 5 over 4 minus t plus 3 over 20 t squared. So we've done the differentiation, let's check the question. When the acceleration of p is instantaneously 0, so when a equals 0, 0 equals 5 over 4 minus t plus 3 over 20 t squared. Let's get the quadratic in the form we prefer. Multiply that by the 20, so we get 3t squared minus 20t plus 20 over 4 is 5. 5 times 5 is plus 25. That looks like it'll factorise, so we can just use our grid quickly. 3t squared plus 25, so numbers that multiply to give 3 times 25 and add to give negative 20. Think of the 25 as 5 times 5, so that looks like 15, and 5 could be used to give the minus 20, and they most need to be negative, so we get negative 15t minus 5t. Take the 3t out as a factor, t minus 5 minus 5. So we've got 3t minus 5 and t minus 5. So t equals, add the 5 across, 5 over 3, and t equals 5. And we're all pleased with ourselves, but as usual, we better just read the question, check that we've answered it. So we read back. Find the values of t, done that, and the corresponding values of v. So the corresponding values of v. So we've got to find the v values at these times. So t equals 5, v equals, so at t equals 5, v is equal to, probably best to use the original equation, 1/20 of t, which was 5, times 5 minus t squared, so 5 minus 5 squared. So that gives 0 very quickly because this bit is 0 and they're all multiplied together. At t equal 5 over 3 then, v equals 1/20 of 5 over 3 times 5 minus 5 over 3 squared. So 1/20 times 5 over 3, the 5 and the 20 cancel to give a quarter, so we get 1/12 of. Think of the 5 as 15 over 3. So we then get this as 15 minus 5 is 10 over 3. 10 over 3 squared. So that is 100 over 9 times 12, which is 90, 108, which is 50, or 25 even over 27, both divide by 4 meters per second, which is approximately 0.9, I would think, meters per second. Okay, and I think that then is a check, read through the question again, find the values of t and the corresponding value when the acceleration of p is instantaneously 0. We have finished that then, and I hope that went reasonably well for you as a practice. I'll be releasing the actual test on probably Thursday, so tomorrow. Okay, hope that has helped you with your revision.